Let's do some proving trig identities. Let's do 10 problems in this video, or if it runs long, I might cut it. But the goal is to do 10 problems. It'll probably get harder as we progress. These problems are taken from the Stewart Precalculus textbook. I believe this is chapter 7. I don't know what edition. I can put it in the description, but this is the chapter 7 review, okay? And this is number 1. We got to prove this trig identity. It says sine theta times cotangent theta plus tangent theta equals secant theta. So most teachers, I will say that a lot of teachers require different things, but most teachers, from my experience, only lets you touch one side only. Okay, so you could like start from the left-hand side. That was really a big mark there, probably because I'm zoomed in. But as I was saying, most teachers only let you start from one side to get to the other. So you can't touch both sides at the same time, okay? So I'm going to mimic that here. And the general tip is you want to start from the more complicated side. In this case, it'll be the left-hand side, and get that more complicated side to the less complicated side. In this case, the right-hand side. It's kind of like simplifying. You want to start from something complex and get it more simple. Break it down into more simple things, okay? Instead of starting from simple, I'm purposely making it more complex, okay? It's also works, but it's less intuitive for most. Okay, so with that said, let's rewrite the left-hand side. Sine theta times cotangent theta plus tangent theta. Okay, there's lots of ways to do these probably. I'm just solving these live, okay? These are the best types of questions, by the way, because the answer is right there. You have to get a secant theta somehow, okay? So why don't we distribute, or before that, let's change everything in terms of sine and cosine. This is one approach. So cotangent theta is actually cosine theta over sine theta. And then tangent theta is sine theta over cosine theta. All right, now let's distribute the sine theta to both terms. So we get cosine theta plus sine squared theta over cosine theta. Okay. Now what do you do from here? Well, maybe we could change that sine squared in terms of cosine because we want it to be a secant in the end. So maybe we want everything in terms of cosine, and secant is 1 over cosine, okay? So that's what I'm thinking. 1 minus cosine squared theta is sine squared theta, okay? So then it becomes cosine theta. Let's break up the fraction. 1 over cosine theta minus cosine squared theta over cosine theta. I'm doing very baby steps here to show you the thought process, okay? So let's simplify. 1 over cosine is secant, and this simplifies just to cosine theta. So these two cancel, and you're left with secant theta, and this matches the top, the right-hand side, okay? So maybe your teacher needs like left equals right-hand side, and then left-hand side, something like that. I saw the textbook requires that. But honestly, I don't really care for that. My teacher never cared for that either when I was in pre-calculus. Okay, so just do what your teacher said, but this is a thought process, okay? That's one way to approach that one. Okay, number 2, this is secant theta. Let me zoom in. Secant theta minus 1 times secant theta plus 1 equals tangent squared theta. So again, the left-hand side is more complicated, so maybe let's touch that side to get it to the right-hand side, okay? So let's FOIL this left-hand side out. So it'll be secant squared theta plus secant theta minus secant theta minus 1, okay? Oh, okay, let me be precise. Let me rewrite the first line as well. Okay, by the way, that was the difference of 2 squares, so we could have, let me write it first. So we could have just got rid of the 2 middle terms over there, okay? So this is equal to secant squared theta minus 1. And by the Pythagorean identity, this is just tangent squared theta. There we go. Not too bad for this one. Next, number 3. This one is cosine squared x, cosecant x minus cosecant x equals negative sine x. So again, the left-hand side is more complicated. So let's work on that side. immediately I'm thinking, why don't I just factor out cosecant x? Then we get cosine squared x minus 1. Okay? Okay, let me see if we got it again. Let me rewrite the left-hand side first. Cosine squared x, cosecant x minus cosecant x equals this thing that I just wrote previously. And then we can even do negative cosecant x. Let's factor out negative 1, so it becomes 1 minus cosine squared x. Okay? So this is minus cosecant x times sine squared x by the Pythagorean identity. And then, what is cosecant? It's 1 over sine x times sine squared x. This simplifies to negative sine x, and we're good for this one. Okay, next, number 4. 1 over 1 minus sine squared x equals 1 plus tangent squared x. Okay, so you might be tempted to do this. 1 plus tangent squared x is secant squared x, and then 1 minus sine squared x is cosine squared x, so that secant squared x is equal to secant squared x. This is precisely what most teachers don't allow you to do. You can only touch one of the two sides. Here, you touch both sides. Not allowed for most teachers. You know, it really doesn't matter, okay? All right, so which side do we want to work with, the left or the right? In this case, maybe let's do well, we already had the answer, right? So it doesn't really matter. It's about the same amount of work for each one. So I'll pick the left-hand side though. 1 minus sine squared x equals 1 over cosine squared x. That's by the Pythagorean identity. And then this, by definition, is secant squared x. And by the Pythagorean identity again, secant squared is 1 plus tangent squared x. And there we go. Okay. Next, I believe this is number 5 now. Cosine squared x minus tangent squared x over sine squared x equals cotangent squared x minus secant squared x. Okay. The left-hand side looks more complicated, so let's work on that side. By the way, if one side doesn't get you anywhere, you can abandon it and try working on the other side. Or, let me write this first, I can't multitask that well. Or you can start touching the other side if you're really stuck and then just erase it, because if you get to inequality, you could just kind of copy paste, okay? All right, so why don't I break up the fraction basically. So cosine squared x over sine squared x minus tangent squared x over sine squared x. Okay, so this first term becomes cotangent squared x, okay? Now, how is the second term going to be a secant squared x? How can we change this? Well, tangent squared is sine squared x over cosine squared x. Yeah, and then we have another 1 over sine squared x already there. So this becomes cotangent squared x minus 1 over cosine squared x. And by definition, or really identity, whatever you want to call it, this is secant squared x. And there's our original guy. Let me zoom out so that it'll fit. Okay. Whoops. My bad. I need to. There we go. Okay. It's probably the original screen says. Okay. Next, number 6. 1 plus secant x over secant x equals sine squared x over 1 minus cosine x. Okay. So both sides look equally complicated. So which side do I want to work with? Maybe let's start with the left-hand side again. I don't know. We might abandon this. 1 plus secant x over secant x equals, well, what can I do? Maybe let's change everything in terms of cosine. So secant is 1 over cosine. Okay? And then I can, let me write it one more time to do the proof neatly. Multiply both the top and bottom by cosine of x. Multiplying by 1, not changing anything, okay? So the top becomes cosine x plus 1, the bottom becomes 1. So cosine x plus 1 over 1 equals the right-hand side, sine squared x over 1 minus cosine x. Does it even look close? I feel lost. So maybe let's abandon this method. All right, because I don't even know. I could probably get to it if I really works there, but at the moment, if I'm on time test, I don't know how to get to from 1 plus cosine x to the sine squared over 1 minus cosine x. So let's start from the right-hand side now. Sine squared x over 1 minus cosine x. Okay, well, the top, sine squared x is 1 minus cosine squared x, yeah? And the top, I can actually factor. 1 plus cosine x is the difference of two squares. 1 minus cosine of x over 1 minus cosine of x. Okay? Actually, see, look. Didn't I get 1 plus cosine of x earlier? But now I'm stuck again. So maybe I shouldn't have erased it. Okay. So let's rewrite it what I had again. Okay, this is a learning point here for you guys if you're stuck on these trickier ones. Okay, so what did I do earlier? I did 1 plus 1 over cosine x over 1 over cosine x. And then multiply both the top and the bottom by cosine x. Yeah? So then this became 1 plus cosine of x. So look, now basically this line right here is equal to this line right here, right? So I went down this way. Now I can go up this way. Okay, this is my point. If you're stuck, you can start working on the other side. And now we're going to copy this over, but we're going to reverse it basically. Okay, so let's do 1 plus cosine of x times cosine x over cosine x. Okay, so now that's exactly what I did over here, right? Right here, where I'm underlining. All right, so what do I get? I get cosine x plus cosine squared x over cosine x. All right. Or, okay, see, now I have to look, I'm looking even back right here right now. That's why I'm kind of pausing, okay? So, or instead of cosine x, why don't I do 1 over cosine x? Basically, what if I do secant x? Okay, so then I would get secant x plus 1 over secant x. And actually, look, that's my, it's kind of small, but that's my right-hand side. Sorry, left-hand side right there. So it's kind of small, but there we go. You can see the whole thing now. All right, so now on the test, we erase this over here, and we're done. So again, the point I'm trying to make is I got stuck. So I started working on the other side. I just erased it. But I got to the same point, 1 plus cosine x. So I can take the steps I did from both the sides and combine them. You just got to kind of reverse the order for one of them, which is what I did over here. Okay? It was a good practice problem, and for me to demonstrate what happens when you're stuck. Okay. Next, number 7, cosine squared x over 1 minus sine x equals cosine x over secant x minus tangent x. Which side do we want to work with? Looks pretty similar in terms of difficulty on both sides. So let's start with the left-hand side again. Okay. So on the top, I can change it to 1 minus sine squared x over, actually, now that I'm thinking about it, maybe let's start with the right-hand side, because I can change everything in terms of sine and cosine over there. So let me write it again first, secant x minus tangent x. So cosine x on top, and then secant is 1 over cosine x, and the tangent is sine x over cosine x. Yeah, so this is a little more clear to me. Okay, so now I can multiply both sides, both the top and the bottom, sorry, by cosine x. So the top I would get cosine squared x, and the bottom I would get 1 minus sine x. And there's our answer right there. Okay. So in this case, at least for me, it was much easier to start from the right-hand side because I could change everything in terms of sine and cosine. Okay, which is the left-hand side. Everything's sine and cosine on the left-hand side. All right, next, number 8, 1 minus tangent x times 1 minus cotangent x equals 2 minus secant x cosecant x. Okay, so I'm thinking let's work on the left-hand side. We can FOIL it out. Okay, so this becomes 1 minus cotangent x minus tangent x plus tangent x cotangent x. Tangent x times cotangent x, that just gives us 1. So then this would be 2 minus cotangent x minus tangent x. Okay. So somehow this minus cotangent x minus tangent x is equal to secant x cosecant x. Okay, so how can we do that? Well, maybe let's change things in terms of sine and cosine again. So cotangent is cosine over sine, and tangent is sine over cosine, okay? So what if I factor out a -1 first? Keep hitting the erase button, my bad. Okay. All right, so let's look at the top again. You can use the right-hand side as a hint. We need a secant and cosecant. So maybe let's factor. First, let's do 1 over cosine x, which is secant x. Okay, I'll write secant later. So on this first one, I would get cosine squared x over sine x. The second one, I would just get sine x because I factored it out. The first one, there was nothing on the bottom, so I have to put one more power on the top, so it becomes a square, okay? And similarly, let's factor out 1 over sine x as well. So this would become cosine squared x, and that becomes sine squared x the second term. Okay? Look, this is 1 by the Pythagorean identity. So it becomes 2 minus secant x cosecant x. And there's our answer right there. Okay, so once again, I chose to do the left-hand side because you can expand it out, okay? And then right away, I saw the 2's. That's promising. So we had to force this minus cotangent x minus tangent x to be minus secant x cosecant x. So that started changing everything in terms of sine and cosine to help me see things a little better. All right, number 9. Sine squared x cotangent squared x plus cosine squared x tangent squared x is equal to 1. Clearly, the left-hand side is more complicated, so let's work on that. Sine squared x, cotangent squared x, cosine squared x, tangent squared x. Let's change everything in terms of sine and cosine. So cosine squared x over sine squared x is cotangent. And then sine squared x over cosine squared x is tangent. Okay, so things cancel. So we get cosine squared x plus sine squared x. That's equal to 1. We're done for this one. Okay, oftentimes we change everything in terms of sine and cosine to help us out, especially if there's mixed sine, cosine, tangents, cotangents, okay? Okay, number 10, this will be the last one for this video. Tangent x plus cotangent x quantity squared is cosecant squared x secant squared x. The left-hand side, we can expand out to simplify to cosecant squared x secant squared is what I'm thinking. So let's expand the left-hand side. So tangent x plus cotangent x quantity squared equals tangent squared x plus 2 tangent x cotangent x plus cotangent squared x. Well, tangent x, cotangent x, they multiply to 1. So we get, and then this 2 we can break up as 1 plus tangent squared x. Okay, and then we have 1 plus cotangent squared x. Okay, so this is actually secant squared x plus cosecant squared x. But our answer is the product of these two. So did we do something wrong? Or maybe we have to persist and continue. Okay, so it's a product of things. Maybe let's change everything in terms of sine and cosine, different representation to help us see things, maybe. Okay, so now what do we do from here? Well, what if I just factor a 1 over cosine squared x out? Then this would be 1 plus cosine squared x over sine squared x. Okay, so this is 1 over cosine is secant squared x, and this is 1 plus cotangent squared x. And look, this gives us the product now. Times, let me write the times a little better, times cosecant squared x. Okay, there we go. So interesting. Secant squared x plus cosecant squared x is apparently the same thing as the product, secant squared x times cosecant squared x. Interesting finding that we did while doing this problem. All right. Okay. So hopefully you got some tips from this video. There's going to be a part 2 because there's like 20 something of these problems in this chapter review. But hopefully you got some tips to get you going if you were struggling for these. So again, pick the more complicated side to kind of simplify and reduce down to the less complicated side. If they're kind of even looking for both, like this one, pick your poison. If one side doesn't get anywhere, start touching the other side as well, and then maybe you'll converge, like in, which one was it? I would think it was this weird one, right? Over here. Okay, hopefully this is helpful. I'll hopefully see you in the next video as well. Bye.